Welcome back. I hope you all enjoyed your no school fog day. I am making a video on our day off, so hopefully you get something out of it. Here's your warm-up. Go ahead and pause the video and do those. So 10 squared times 10 cubed. Remember what we do. This is what we learned in the last chapter. 10 to the fourth divided by 10 cubed. What do we do with those exponents? Okay. So recall, which this would help you with your warm-up, so if you didn't remember how to do that, when you multiply with the same base as in your first warm-up, you add the exponents. And then when you're dividing with the same base, you subtract your exponents. So that's the stuff in the last chapter that we talked about. Okay? But that's going to help us when we multiply and divide in scientific notation. Again, you guys have done this in science class, so this is kind of like a refresher. So when you multiply two numbers that are in scientific notation, you multiply the coefficient, which is the number in front of the 10 to the whatever, then you add the exponents and keep the base 10. Okay. So let's do an example. They have lots of word problems in the book notes, but today you're going to have a worksheet for homework. So this problem, it says an Olympic-sized swimming pool is about 5 times 10 to the 1 meters long and 2.5 times 10 to the 1 meters wide. Find the area of the water surface. Now remember when I first talked to you guys about reading story problems, you should read them 2 or 3 times. So let's read it again. An Olympic-sized swimming pool is about 5 times 10 to the 1 meters long and 2.5 times 10 to the 1 meters wide. Find the area of the water surface. So if I'm thinking about this, I have my pool. Drawing a picture always helps. Okay. And my width is 2.5 times 10 to the 1. And my length is 5 times, not point, 10 to the 1. And they want to know the water's surface area here. So remember, it's finding the area of a rectangle, which is length times width. So multiplying these. So I have 2.5 times 10 to the 1 times, I'm going to put these in parentheses just to make sure I know where everything goes together, times 10 to the 1. So the parentheses aren't necessary, but it just kind of helps me to see that this is one scientific notation number and this is the other. Okay, so now my rule in multiplying, if I look back up here, it says multiply the coefficients, then add the exponents. So if I'm looking here, the coefficients are 2.5 and 5. And this you would be allowed to use a calculator for. So 5 times 2.5 is 12.5. When I look at my bases, or my tens, and it's 1 and 1, so it's the same base and I'm multiplying, so I add my exponents. So it's going to be 1 plus 1, which is going to be 1.25, I'm sorry, 12.5 times 10 squared. Okay. Now it wants my answer in scientific notation. This is not yet in proper scientific notation because 12 is not between 1 and 9. So I'm going to move my decimal over 1. So I'm going to have 1.25, and because I moved it to the left 1, I bump up my exponent by 1. So times 10 cubed. Once I move that decimal over one spot, and I would want to make this number bigger at the final answer, I need to make it 1 more positive. Okay. Go ahead and pause the video if you need to catch up on that. I'm going to move on to the next example. So it says the length of the Aztec Stadium in Mexico is about 1.05 times 10 squared meters long and about 6.8 times 10 to the 1 meters wide. Okay. Find its area. So again, we have a rectangle saying the stadium. So it's 1.05 times 10 squared by 6.8 times 10 to the 1. So again, that's our important information. So you should always read it again. The length of the Aztec Stadium in Mexico is about 1.05 times 10 squared meters long and about 6.8 times 10 to the 1 meters wide. Find its area. Okay, so I'm finding the area, which again, area of a rectangle is length times width. So again, I'm doing 6.8 times 10 to the 1 times 1.05 times 10 squared. And again, I'm just putting this in parentheses so that way I can separate the two scientific numbers. I don't want to confuse what goes with what part. So again, when I'm multiplying, I can multiply the coefficients. And again, this is something you could use the calculator for. But 6.8 times 1.05 is 7.14. And then I get to combine the tens. And again, because they're the same base and it's multiplication, I add the exponents, which is going to give me 10 cubed. And this should be meters squared because it's meters times meters. Because I should always put a unit. I forgot to put a unit on my last one, but you should be putting units if they give you units. Okay. And this is written in proper scientific notation already because the 7 in front of the decimal is between 1 and 9. So I don't have to make any changes there. So this will be my final answer with my beautiful units. Okay. So go ahead and pause there if you need to catch up on writing that. We are going to move on to dividing. So when you divide the coefficients and then you subtract the exponents. Okay. So I got that example there. So what I'm looking at here is I have 6.4 times 10 to the 23rd, all divided by 3.3 times 10 to the 23rd. So I look here and I look at just my regular old-fashioned numbers, the coefficients. So 6.4 divided by 3.3. So this would be where, again, I would pop my calculator out. 6.4 divided by 3.3 is 1.9 times 10 to the 23 minus 23, because I subtract my exponents, which would be 1.9 times 10 to the 0. And we know from our rules, this whole thing, since it's to the 0 power, this piece becomes 1. I don't change the exponent, I change the whole number. So the 1.9 didn't have a 0 power, there's no power right here with this guy, so that stays, times 1. And 1.9 times 1 is equal to 1.9. And this is improper. They wanted you to have an actual number, but if you wanted it in scientific notation, you would leave it as this. But if you want an actual number, you could leave it as this. So I would accept both answers. Okay. Sometimes they're in the back of the book. Well, you guys have a worksheet on this, so I would leave it in scientific notation on your worksheet today. Okay. I have one more example that's a